Hello everyone, welcome back to the channel Knowledge for You. Today I am going to discuss the most important 5-mark question of the subject microprocessors and microcontroller. This question is from second unit, that is architecture of 8051 microcontroller. And one more thing, this question is common and this subject is common for ECE, EIE, instrumentation branch and EEE branch. So let's start here. So for the coming mid-1 exam, you are going to expect this question for 5 marks. This functional block diagram of 8051 microcontroller. Before that, in the syllabus, which microcontroller we are discussing means the IC number of that microcontroller is 8051. It is 8051. So let's start the block diagram here. So in the middle we have a bus here. So first we have to draw these bus lines, and next we have the CPU, which is the brain of the computer, central processing unit. And here above to the CPU we have interrupt control, and next here 4 kilobytes of ROM, next 128 bytes of RAM, and 2 timers it has, that is timer 0 and timer 1. Next it also has 2 counters also, that is counter inputs we have applied. So remember this 8051 consists of 4 kilobytes of ROM and 128 bytes of RAM, and interrupt control we have. For that we are applying the external interrupt signals like this. So this is the CPU. In order to operate the CPU, the clock frequency for this processor will be provided by means of an oscillator. Usually this oscillator is a quartz crystal oscillator. So this oscillator provides a frequency to the processor. So this is the block diagram of this, and here below to this bus we have a bus control, and next 4 input output ports. Totally it has 4 input output ports, port 0, port 1, port 2 and port 3. And next one serial port is there, that is transmit data and receive data. So these two signals are used for serial communication. To transmit the data we use transmit data pin, and to receive the data this microcontroller uses RxD pin, that is receive data pin. So overall this is the block diagram. Now we have to discuss each and every block in detail now. So remember, in the middle you have to draw the buses, and above to that we have 4 kilobytes of ROM, next 128 bytes of RAM, and next 2 timers, it has timer 0 and timer 1. Next interrupt control, for that it receives external interrupt signals, and here it has a microprocessor. Next the frequency of the processor will be provided by means of a quartz crystal oscillator, and next it has a bus control and 4 input output ports and serial ports it has. So from this block diagram you can also remember one of the question like what are the important features of 8051 microcontroller. Then you have to write under features, you have to write it has 4 kilobytes of ROM, next 128 bytes of RAM. It consists of 2 timers, that is timer 0 and timer 1, and 2 counters. It has 4 input output ports, port 0, port 1, port 2, port 3. Next it has serial porter. It is used for serial communication. So it has 2 signals, one is transmit data, second is receive data. Next it also has external interrupts. So these are the points you can cover under features of 8051 microcontroller. So that feature question is also important for 3 marks. And this 8051 is available in 40 pin IC package, and basically it is a 8-bit microcontroller. It is a 8-bit microcontroller. It has 4 input output ports. It has 4 kilobytes of ROM and 128 bytes of RAM, and 2 timers, timer 0 and timer 1, along with 2 counters. So let's start the functioning of each and every block in detail. So here 8051 is a 8-bit microcontroller. It is one of the important point of 8051 microcontroller. Okay, it is a 8-bit microcontroller. It is available in 40 pin IC, and it requires 5 volts of power supply. So let's start the first block, that is oscillator and clock generator. So here I am focusing only the main important point that you have to cover for writing. I'm not going to discuss each and every point. So whatever the points I am discussing, so please write these points only in the exam. That will be enough for you. So clock, generator and oscillator. So all the operations in the microcontroller are synchronized by means of a oscillator clock. That means whatever the task which is performed by the microcontroller, that will be synchronized by using this oscillator clock. So for this purpose a quartz crystal and capacitors are employed. Okay, so in order to perform the synchronization of these operations, we are using a quartz crystal. This is the quartz crystal along with the capacitors it has. Okay, so all the operations in the microcontroller are synchronized by means of a oscillator clock. For this purpose, a quartz crystal, because it is a stable oscillator, so quartz crystal oscillator is preferred along with the capacitors. And this crystal, this clock crystal, it provides maximum frequency of 1 megahertz and minimum frequency of 16 megahertz. So listen once again here, only 3 points you have to write. The first one is all the operations in the microcontroller are synchronized by using a clock oscillator. So for this purpose, a quartz crystal oscillator is used along with the capacitor, and it has a maximum frequency of 1 megahertz and minimum frequency 16 megahertz. So this is about the oscillator and clock generator. And the second one we have, the second block is ALU. So ALU is one of the important part of the microprocessor CPU. So ALU is a 8-bit register. So basically ALU is a 8-bit unit. It performs all the arithmetic and logical operations. So the arithmetic operations like addition, subtraction, multiplication, division, increment and decrement operations are going to be performed by it. And apart from that, it also performs logical operations like AND operation, OR operation and XOR operation. And next it performs compare, rotate and complement operations too. Okay, so these are the points you have to cover. First one, it is a 8-bit unit. It performs all the arithmetic operations like addition, subtraction, multiplication, etc. And next, it also performs a logical operation like AND or XOR. Okay, and performs compare, rotate, and complement operations. Along with that, you have to write the 8051 controller. Microcontroller contains 34 general purpose registers. It has what? So this is one of the important 1 mark question. How many general purpose registers it has? So basically it has 34 general purpose registers, out of which 2 of them are called math register, that is register A and register B, and rest of the 32 registers are known as bank of registers. So it has 34 general purpose registers, out of which 2 are known as math register, that is A and B, and rest of the 32 registers are used for bank of registers. And let's discuss what is A and B register. So A stands for accumulator. So this is one of the important 1 mark question. What is accumulator? Define A. A nothing but accumulator. So basically it is a 8-bit register. Okay, the capacity of accumulator is what? It is a 8-bit register. It is used for data transfer and arithmetic operations. And next, it is the accumulator is the by default destination register, we can say, in which the result of the ALU is going to be stored. The result of the ALU is going to be stored in accumulator. The result of the ALU is going to be stored in the accumulator. It is a by default destination register to store the result of ALU, and it is a 8-bit register. Next we have B register. So it is also used. B register along with accumulator. B register is preferred in case of multiplication and division. So do remember, accumulator is 8-bit register. Similarly, B register is also 8-bit register. Accumulator is a by default destination register to store the result of ALU. Means while performing arithmetic, addition operation, subtraction operation, the ultimately result is going to be stored in accumulator only. But when the B register is going to be used, the B register is used in case of multiplication and division. In case of multiplication and division. So while performing multiplication operation, the result of that is upper 8-bit result is stored in B register. Upper 8-bit result of multiplication is stored in B register. This point, upper 8-bit result of multiplication is stored in B register, and the remainder is stored in B register in case of division. So upper 8-bit in case of multiplication and remainder in case of division. So these two operations or these two results are going to be stored in B register. And next we have PC, stands for program counter. So it is also one of the important 1 mark question. So PC program counter is a 16-bit register. This is the only register whose capacity is 16 bits, and rest of the registers are of 8-bit register only. So PC stands for program counter. It is a 16-bit register. It is used to store or hold the address of the next instruction to be executed. The address of the next instruction to be executed. Okay, so for example, if I write a program like move A, #08, this is the assembly language program, and next instruction I have written move B, #09. Assume the memory address of first instruction is 4000 and the second instruction is 4001. Then this is the address of this instruction, and this address is going to be stored in PC. That is 4001. Okay. So always the microcontroller refers to program counter. What is the address saved in the program counter? So program counter basically it is a 16-bit register, 16-bit register which holds or stores the address of the next instruction. It holds. So this is the address of the next instruction. For this is the next instruction. So it stores the address of the next instruction to be executed by the controller. Next we have internal ROM. So already we have discussed in the functional block diagram that 8051 has 4 kilobytes of on-chip ROM. On-chip ROM means this ROM is already inbuilt on the particular microcontroller. So we are not connecting this memory externally to the microcontroller. So this is an inbuilt 4 kilobyte of on-chip ROM. Okay, 4 kilobyte of on-chip ROM, and it addresses from 0000H to 0FFF. Internal ROM, the 8051 microcontroller has 4 kilobytes of on-chip ROM. So it has 4 kilobytes of on-chip ROM. This ROM is already available on the particular chip, and it has a starting address of 000 and end address is 0FFF. Then how do we get this location address? Means 4 kilobytes means 4 into 1024. If we multiply this, we get what? 4 for the 16, 1, 4 to the 400, 4 1 4, 4096. So since always we start from 0, the end address will be what? 4095. 4 kilobytes. Kilo means what? 2 power 10. 2 power 10 means what? 1024. After multiplying this, we have 104. After multiplying 1024 into 4, we have got 4096. Then the starting address is 0 and the ending address is 4095. Then divide with 16. So 16 1 is 16, 16 to 32. If we divide it, we get the FFF as reminder. So do this, you will get it. So 0FFF is the reminder we get. So the starting location is what? 0000 and ending location is 0FFFH. So these are the addresses location pointed by the internal ROM. It has capacity 4 kilobytes. And next we have internal RAM. So this question is also important for 3 marks. The internal RAM. So internal RAM capacity is 128 bytes of RAM in the 8051 microcontroller. So 128 means if we convert into address locations, 128, so 0 is the starting one and ending one will be 127 bytes. So divide this 127 with 16. Then we get 16 1s are 16, 16 7s are. We get then remainder will be what? 15 we get remainder. So 15 means F. So 7F we get. So the starting address is 00 and the ending address is what? 7F. So this is the address locations which is pointed out by the internal RAM, whose capacity is 128 bytes. Now, out of this 128 bytes, it is classified into 3 different types. The first one is out of 128, we are using only 32 bytes. The first 32 bytes and whose location is from 00 to 1F. Again, how do we get this 1F? Then 32 means start from 0 and end address will be 31. So divide with this 16, 16 1s are 16, remainder will be 15 means 1F. So 1F is the ending address and the starting address is 00. The first 32 bytes are used for register banks. The first 32 bytes whose location points out by 00 to 1F, these are used for register banks and the stack. And next 128 means out of 128 we have realized 32 and the rest of the 96. Out of 96 we have 16 bytes. That's location is from what? 20 to 2F. Okay, already we have 00 to 1F. After 1 we have what? 2. F means 0. So 20 to 2F. The next 16 bytes they are used for bit addressable reader write. Okay, so what is the memory capacity of bit addressable? It is 16 bytes. It is 16 bytes. The next 16 bytes whose location from 20 to 2F are used for bit addressable reader write memory, and remaining 128 out of 128, 132 is over, 16 is over. So rest of the 80 bytes. Okay, 128 minus of this, then we get 80 bytes. Remaining 80 bytes, that is from 2F is over. After 2 we get 3. After F again start from 0. So rest of the 30 to 7F. Okay, these are the 80 bytes. These are called as scratch pad. It is used for read and write storage, normally called scratch pad. Next, coming to timers or counters, it has 2 timers or counters and each timer is of length 16-bit. Okay, each timer capacity is 16-bit register. So these timers work in 4 different modes, and it's also one of the important question. The timers of the 8051 controller works in how many modes of operation? Then the answer is 4 modes. Mode 0, mode 1, mode 2 and mode 3. So timers are used to generate the time delays and the counters are used to count the number of events happening outside the controller. Okay, timers are used. So why do we use timers? To generate the time delays, and counters means it used to count the number of events. And next, IO ports. The 8051 has four input output ports. How many ports it has? 4 IO ports, and each IO port is of 8-bit length, or it has each input output port, or each port has 8 pins. Okay, total 8 for the 32 pins are allocated for 4 IO ports. So this question may be asked, so how many pins are allotted for input output ports of 8051 controller? Then the answer is 32 pins, because it has 4 input output ports and each port is of 8 pins. So 8 into 4, 32 pins. So these are known as port 0, port 1, port 2 and port 3. Port 0 can be used for multiplex. So this is also important. Port 0, why do we use port 0? It is used for a multiplexed lower byte address or data bus. Multiplexed means it has combined, because single pin can be used to perform both operation data bus as well as address bus. That's why we are calling it as multiplex address or data bus. Okay, and to separate this multiplex address or data bus, 8051 uses a pin so-called ALE, that is address latch enable. Address latch enable, which demultiplexes or separates the address bus from data bus. That is also one of the important question. What is the function of ALE? ALE stands for what? Address latch enable. It is used to demultiplex address bus from data bus. Okay. So port 0 can be used for multiplex address or data bus, lower byte address or data bus. Similarly, port 2 we have, along with port 0 we have port 2, and it is used for higher order, higher byte, okay, higher byte address bus. Whereas port 1 can be used for an input output port, and port 3 is dedicated IO port. Okay, so this question is important. Role of port 0, port 1, port 2 and port 3. Port 0 can be used as multiplexed low byte address or data bus. Port 2 is used for high byte address bus. Port 1 can be used as an input port or output port. Port 3 is a dedicated IO port. Next we have interrupt controller control. Okay, this 8051 has total 5 sources of interrupts. Okay, it provides total 5 sources of interrupts. It can be either external or internal, but all these 5 sources of interrupts are external interrupts. Okay, 8051 has 5 sources of interrupts. They are interrupt 0, interrupt 1, next serial port interrupt, timer 0 interrupt and timer 1 interrupt. Only these points you have to write. Okay, it has total 5 sources of interrupt, interrupt 0, interrupt 1. All these are external interrupts to 8051 controller. Serial port interrupt, timer 0 interrupt and timer 1 interrupt. And the next one we have serial port. So it also provides serial port communication, the serial data communication that can be achieved by using 2 pins. One is transmit data pin, second is receive data pin. By using transmit data pin, the serial data can be transferred and that can be received by using RxD pin. And the last one, it has bus control. So bus control, it is classified into 2 types. So it is of 2 types or 2 kinds of buses available. One is data bus, second is address bus. Data bus is used to transfer the data and address bus is to provide the address information but not data. Okay, the purpose of address bus is to transfer the information, transfer the address but not the data. So this is all about the architecture, you can say the functional block diagram of 8051 microcontroller. One of the most important question for 5 marks for the upcoming mid-1 examination of SB TET. So like, share and subscribe to my channel. Thank you.